Hi friends, today we are going to talk about hybridization. So hybridization is a very important concept in chemistry which talks about molecular geometry and atomic orbitals, and it explains the bonding in atomic orbitals. So it gives us the molecular geometry of the molecules. So what exactly is hybridization? Hybridization is generally intermixing of two or more atomic orbitals. Intermixing of two or more atomic orbitals. Two or more atomic orbitals. So what do I mean by intermixing of two or more atomic orbitals? So let's take a type of hybridization and we'll get to know about so what exactly is hybridization. So let's take Sp hybridization. So what do I mean by Sp hybridization? As the name suggests, so because it is S and P hybridization, so I'll have one S orbital. So this is my S orbital, and I'll have one more P orbital. So this is my P orbital. So what happens here is they both mix together. So it happens like they mix together and they give me two hybrid orbitals. So they give me two hybrid orbitals, and it looks like this. So there will be a bigger lobe. So this is one Sp hybrid orbital and this is the other Sp hybrid orbital. Now one of the important characteristic of hybridization is if there are two orbitals which are combining together, which are mixing together, then we'll get two hybrid orbitals. This is the first hybrid orbital and this is the second hybrid orbital. Now these two hybrid orbitals are actually equivalent in energy and shape. So the energy and shape of these atomic orbitals will be equivalent. And one of the important characteristic of hybridization is these two sp hybridized orbital, they actually align themselves in a way that the repulsion between these two orbitals will be minimum or least. So they actually make a geometry where they both are at 180 degree angle. So this leads to a geometry of linear structure. So whenever there will be sp hybridization, the geometry will be linear. Now let's talk about the other type of hybridization, which is sp2 hybridization. So what will happen here? So here I have one S and two P. What happened in Sp was there was only one S and one P, so we got two Sp hybridized orbital. Here we have, because the name is Sp2, we'll have one S and two P orbitals. So this is S orbital, this is P orbital, this is P orbital. Okay, so these three will combine together. These three all will combine together and will give me how many hybrid orbitals? There will be three hybrid orbitals. So they'll look like, so there will be again a bigger lobe and a smaller lobe, again a smaller lobe and a bigger lobe, and same thing here. Now again, if we'll have to look at the geometry in which they'll align themselves, so my one hybrid orbital will look like this. The other one will arrange 120 degree apart from this, and the third one will be like this. So it's a trigonal planar geometry. So sp2 hybridization gives rise to trigonal planar geometry. So there are three hybrid orbitals here. Like this is the first one, first sp2 hybridized orbital, second sp2 hybridized orbital, and this is the third sp2 hybridized orbital. So all these three actually gives rise to trigonal planar geometry. These are the three, and the angle between these is 120 degrees. So the angle is 120 degree. Now if we need to know the S and P character in each and every orbital, so each and every hybrid orbital will have some S and P character. So the S character will be, because there is only one S orbital here and the total number of orbitals are 3. So there will be 1 by third, and for P it will be 2 by third. So this will be 33.33% and this will be 66.66%. So P character of in each of the hybrid orbital will be 66.66% and S character will be 33.33%. Similarly, if we look at Sp hybridized orbital, then here it will be 1 by 2 because there is only one s orbital and there are total number of 2 orbitals. And similarly for P, 1 by 2. So it's 50% here and 50% of P. 50% of S, 50% of P. Now let's look at the third type. The third type is Sp3 hybridization. It's a very important type, Sp3 hybridization. Now I think you guys can guess. There will be one s orbital and 3 p orbital. So these are my 3 p orbitals. This is my 1s, this is p, and this is p. So these all combine together. These all 4 orbitals combine together and give me how many hybrid orbitals? So now there will be 4 hybrid orbitals. So what will be the arrangement for 4 hybrid orbitals? So the arrangement will look something like this. So this is my first, let's say, this is my first atomic orbital. This is my second atomic orbital. This is my third atomic orbital and the fourth one. There will be a fourth one. So this gives rise to a tetrahedral geometry. This is a tetrahedral geometry. So this is a 3D arrangement. This is a 3D arrangement and the geometry is tetrahedral where the angle is 109.5 approximately. The approximate angle is 109.5 degree. And if we talk about S and P character here, the S character will be 1 by 4 because the S orbital, there is only one S orbital and total number of orbitals are, this is S orbital and this is total number of orbitals. Total number of orbitals. So 1 by 4 and for P it will be 3 by 4. So this is 25% S character and 75% P character. 75% P character in Sp3 hybridization and it will look something like this. So the arrangement, so the geometry they gives, so the geometry in case of Sp hybridization is linear and then in case of Sp2 hybridization it is trigonal planar and in case of Sp3 hybridization it is tetrahedral. So now in the next video we'll look at the examples of Sp hybridization, Sp2 hybridization, Sp hybridization, Sp2 hybridization and Sp3 hybridization. And we'll also look at one of the important properties of carbon, that carbon shows all 3 types of hybridization. We'll take examples and we'll explain all 3 types of hybridization in the next video. Thank you.